Wavelength of a metal is 5000 angstrom. Find the work function in electron volt and the kinetic energy of photoelectron in electron volt. It's a very simple question. If you know the previous thing very clearly, we said lambda equal to 1242 electron volt nanometer by energy, or energy is equal to 1242 electron volt nanometer by lambda. If you know the lambda, you can find energy of the radiation. If you know the energy, you can find the wavelength of the radiation. And here threshold wavelength is 5000 angstrom. That means energy corresponding to threshold wavelength is exactly equal to work function. Hence, if you substitute energy as work function, this lambda becomes threshold wavelength. Hence, work function of a metal is 1242 electron volt nanometer by wavelength, which is called threshold wavelength. Here they are saying threshold wavelength is 5000 angstrom. So when you substitute in this formula, you just have to use this as, substitute this in nanometer. So the work function of the metal is 1242 electron volt nanometer by 5000 angstrom. So we already said 5000 angstrom equal to 10 less nanometer. So 5000 angstrom is 500 nanometer. So I'm substituting threshold wavelength 500 nanometer. So nanometer will be cancelled. Hence the work function of the metal is 1242 by 500. 2 zeros you can cut this here. So 1242 by 5 or 12.42 by 5 is equal to 2.484 electron volt. Hence we have found the threshold. Using threshold wavelength, we have found the work function of the metal. We know using photoelectric equation that kinetic energy of the photoelectron is incident energy minus the work function. Now in this problem they have given what is the kinetic energy if the radiation of 4000 angstrom falls on it. So you have to find the energy of this 4000 angstrom. It is like this. So this is a plate and radiation of 4000 angstrom, that means 400 nanometer falls on it. If you know the energy, the work function here is, we have already found 2.484 electron volt. So this incident energy minus work function will give you the kinetic energy of the electron. So let us try to find incident energy. Again use the same formula to find energy using the wavelength. Energy of the radiation is 1242 electron volt nanometer by lambda. Now what is the incident radiation? 4000 angstrom or 400 nanometer. So 400 nanometer. Nanometer will be cancelled. 1242 by 400, it is somewhere around equal to 3.105 electron volt. Nanometer cancels and electron volt remains. So this is the energy of the incident radiation. This is the work function. Hence the kinetic energy of the photoelectron is incident energy, which is equal to 3.105, of which this much energy will be gone in overcoming the work function. So the remaining energy will be this energy minus this energy. So it is 3.105 electron volt minus 2.484 electron volt. So that is equal to roughly 0.6 electron volt. So the kinetic energy of the electron is 0.6 in electron volt. If they ask you to find the kinetic energy in joules, you just have to multiply. The kinetic energy is 0.6 electron volt, but electron volt is equal to 1.6 into 10 power minus 19 joule. So when you multiply these two, you can find the energy in joules. And also this one, if they want to find the velocity, then you just have to equate this. After multiplying with 10 power minus 19 joule, you have to equate it with half mv square, where m is the mass of the electron. That I will do it in a separate problem. You see how to calculate velocity. See, energy of the photoelectron 0.6 electron volt means you can easily find the stopping potential. If an electron is accelerated by 1 volt, it will gain 1 electron volt energy. And if the energy of the electron is 0.6 electron volt, stopping potential is exactly remove this E, stopping potential of this electron equal to 0.6 volt. If you know the kinetic energy of the photoelectron in electron volt, stopping potential is simply what? Remove that E, you will get in V.